Okay, let's continue the discussion of the lines. Okay. So last time we already have the point slope formula. So when you have a point, you have a slope, then the equation of the line through the given point with the given slope. The equation of the line containing the point with the slope is y minus y1 is m times x minus x1. Slope point slope formula. Point slope form. Okay. Now let's talk about another form. There are several forms. It's a slope intercept form. So what is a slope intercept form? When we have a line, if it's not vertical, when it has a slope, so the line is not vertical. When the line is not vertical, with the slope, the line is not vertical. When it is not vertical, it must intersect y-axis. See, if it's not vertical, it will eventually intersect y-axis because y is vertical. So you may have something like this. Assume the y-intercept is b. Assume we know this y-intercept. Y-intercept is b. And the slope is m. Okay. We know that any point on y-intercept has x-coordinate 0. Sorry. All points on the y-axis, not it, y-axis. All points on y-axis have x-coordinate 0. So this point, its y-coordinate is b, its x-coordinate is 0. So the ordered pair is 0b. Okay, the ordered pair is 0b. And then you have slope m, you have this special point 0b. Let's apply the point slope form. Y minus b is m times x minus 0. So by the point slope form, we have this equation. X minus 0 is x, mx. And then we move this b to the right side, so we get y is equal to mx plus b. And this, you see, you know intercept, you know slope. You know intercept, you know slope. This is called the slope intercept form. Okay, so mx plus b is a slope intercept form. Here, intercept means a y-intercept. Okay, so whenever you have a y-intercept, you have the slope. You can directly write down the equation. Okay, so let's check. Example. If m is 2, y-intercept is 3, then the equation of the line is y equal to mx plus 3. Okay, it's very fast. There's no other. It's just coefficient. There's no trick at all. And this slope-intercept form can be used in the reverse way. When you have an equation like this, 2x plus 3, you can also directly say this line has a slope to y-intercept 3. It's like back and forth application. So for a line, assume you already know line is negative 2x plus 7. For this line, we can see, or we can say that the slope is negative 2. The y-intercept is 7. Y-intercept is 7. So you can just read the coefficients and the constant term to determine the slope and the y-intercept. Okay? And sometimes the equation may not be written like this, but you have to do some algebra to find the slope and the y-intercept. If it's right like this, so everything will be straightforward. If it's not, let's see this. Find the slope m and y-intercept of the equation (2x plus 4y equal to 8). Graph the equation. Okay, so how do we do it? We're going to write this equation in this form. So we'll first move 2x to the right side. 2x moved to the right side is negative 2x. And then we're going to divide the equation by 4, because in this slope-intercept form, y has no coefficient. So here you have 4. You divide the equation by 4. Y is negative 1/2 x plus 2. So the slope is negative 1/2. Y-intercept is 2. Right? So whenever you write like y equal to mx plus b, then this is a slope, this is an intercept. And how do we graph it? How do we graph it? So graph it is like this. One, two, three, four, five. 1, 2, -1, -2, -3, 1, 2, 3, 4, So first, y-intercept is 2. So here, this point is here, y-intercept. And then the slope is negative 1/2. Remember, negative 1/2, we move to the left. The numerator is a rise. The denominator is a run. So we first move to the left 2 units. The slope gives us the run, horizontal distance run. And the numerator gives us a rise 1 unit. Okay, so this is the second point. This is 2, this is 1. Negative sign means you go to the left. And then you just sketch it. Yeah, so this is a line. Okay, so that's a graph. When you have intercept, you have slope. You can determine the graph of the equation. Okay, so in the last example, 2x plus 4y equal to 8. This type of equation is called the general form for the line. So this is a third form. The first form is what is first form? First form is a point slope form. Remember that? Point slope form. And second form we studied, we learned is a slope intercept form. And this is the third one, general form. General form is the following. So definition. The equation of a line is in general form one it is ax plus by equal to c. Okay, ax plus by equal to c, where a, b, c are real and a, b are not both 0. Technically, if a, b are both 0, c is 0. It's nothing. It's not interesting at all. Okay, so this is a general form. The advantage of the general form is that it's very symmetric. Ax, by, c, it's very symmetric. It's not like you emphasize x is a input, y is output. You can say x is input, y output, or you can say y input, x output. So there's some symmetry in the writing. Okay. Now let's see some example in this part. Assume we have the general form. We want to graph it, but we don't want to write it like the other forms and do it. We're going to first find the intercept and then graph it. How do we do that? Let's see. Graph the equation. Same equation, 2x plus 4y equal to 8, this one. By finding intercepts, its intercepts. Okay, so you have this equation. Intercepts, remember, in the slope-intercept form, this is a y-intercept. This is a y-intercept. But intercept can be x-intercept, y-intercept. Okay? So to get the x-intercept, you let y equal to 0. You let y equal to 0. Y is 0. 4 times 0. See? 4 times 0 is 0. So you get the 2x equal to 8, x equal to 4. So x-intercept is x equal to 4. To get the y-intercept, let x be 0. So 2 times 0 plus 4 times y equal to 8. 4y is 8 and y is 2. So that's a y-intercept. Now let's see. You 1, 2, 3, 4. X-intercept is 4. 1, 2. Y-intercept is 2. So you have 2 points. We know that every 2 points determine a line. Every 2 points determine a line. So actually, check here. It's a same equation. It's a same equation. If we really label them, possibly this point will be number 4. We didn't make it very specific. Okay, so that's you see here. It's a pure symmetric. For y, for x-intercept, y0. For y-intercept, x0. So just get symmetric way. So that's an advantage of a general form. Okay. So general form, all the lines have the general form. Now let's talk about another advantage of general form. Here we mentioned, we already learned 3 forms: point slope form, slope intercept form, in general. We already learned 3 forms: point slope form, slope intercept form, and the general form. But in the first 2 forms, you both require slopes. We know vertical lines have no slope. Vertical lines have no slope. So vertical lines do not have point slope form and the slope intercept form. Vertical line. So vertical lines have no point slope form and slope intercept form. Whenever you talk about slope, you do not include vertical line. But what is vertical line? Vertical lines are x equal to a. Remember, this is a vertical line. Horizontal line, y equal to b. A, b, whatever, a real number. So we just use a, b to represent the real numbers. So it's not important to clearly evaluate. So x equal to a. X equal to a, let's check. X equal to a can be written as a 1 times x plus 0 times y equal to a. So this is still in the, it's still its general form. This is the general form of a vertical line. Okay, 1 times x plus 0 times y equal to a is 1, b, 0, c is a. So all lines, basically we can say that all the lines have general form, every line has its general form. Every line has its general form. Okay, and sometimes in some textbook, general form also called standard form. That's not the surprising name. Okay, so every line will have a general form, but only non-vertical line will have the point slope form and slope intercept form. Okay, now let's talk about the application in the geometry. So far we only determine the equation, right? There's another thing. This ax plus by equal to c. You see here, x has no higher power, y has no higher power. They are all both power of degree 1. So this is also called linear equation. This is a linear equation with two variables. Okay. Linear equation with two variables. Okay, now let's see the application. Parallel lines. Parallel lines. Let's see what is a parallel. This one. Well, let's assume my sketch is correct. This is a parallel. Parallel lines. You see here, they have the same direction. Basically, parallel means they have the same direction. Then you have the rise, run. You will have the same ratio of a rise and a run. So the same ratio of rise and run means they have the same slope. So for two parallel lines, and we also talk here we talk about the slopes. So rise run is related to the slopes. When we talk about slopes, the lines are non-vertical. Two non-vertical lines are parallel. Two non-vertical lines are parallel if and only if their slopes are equal. Okay, two non-parallels are parallel if and only if the slopes are equal. And because you're talking about two lines, if they have the same slope, same y-intercept, then that's one line. So we want to emphasize you have two lines, same slope, and they have different y-intercept. Same slope, different y-intercept means you have two parallel. Okay? So it can be this way, it can be the other direction. Okay? Now let's do something about this example. And here, two non-vertical lines. What happens if you have two vertical lines? If you have two vertical lines, they are naturally parallel. If two lines are vertical, definitely parallel. Like you have the vertical beams. They do not intersect. Parallel means they do not intersect. Okay, so they are. You don't have to discuss. But if you have one vertical lines, one non-vertical lines, they are never parallel. Okay, so if one line is vertical, one is not, then they are not parallel. They are not parallel. Okay, one vertical lines, one non-vertical lines, they are never parallel. So either they both have slopes or they both not have slope. When they both have slopes, slope must be the same. Okay, let's see the example. Show that the lines given by L1 2x plus 3y equal to 6, L2 4x plus 6y equal to 0, given by this, are parallel. Okay, so to show something a parallel, basically based on the theorem, we just need to confirm they have the same slope, different y-intercept. For line 1, let's find the slope intercept form, because slope intercept form can directly give us slope and intercept. Let's do it. 2x 3y is 6, move 2x to the right side and divide the equation by 3. So this is a slope intercept form. And for line 2, 4x plus 6y is equal to 0. Move 4x to the left side and divide by 6. So let's check. They have the same slope, negative 2/3. This y-intercept is 2, this y-intercept is 0. So L1, L2 have the same slope, negative 2/3, and different y-intercept. Y-intercept 2 and 0. Okay, so that's our observation here, this one, this place. And then they are parallel. They're parallel. Okay, they're parallel. So we can show that two given lines are parallel based on the slope-intercept form. And a common question is that I already know one line and a point outside this line, off the line. I want to write the equation of the line containing the given point but parallel to the given line. So this dotted line should be parallel to the given line. How do I determine it? Determine the equation of this dotted line. Find an equation for the line that contains the point 2 negative 3 and is parallel to the line 2x plus y equal to 6. Okay, so we are talking about the equation of some line containing a point. You have a point. If you know the slope, the problem is solved, right? We know the point slope form. With a point, we need a slope. This line is parallel to the given line, so it should have the same slope as a given line. So we're going to first find the slope from the given line and then apply the point slope form to write down the equation. Okay? So from this given line, we move 2x to the right side. We know that slope is negative 2. The slope is negative 2. With the slope, because the given line, the required line is parallel to it, the required line is parallel to 2x plus y equal to 6, so its slope is also negative 2. We also have slope negative 2. Well, you have slope negative 2, you have a point to negative 3 by point slope form. What do we get? We get y minus negative 3 is equal to negative 2 times x minus 2. Point slope form. Let's simplify it. So y plus 3, here's minus 2x and plus 4. We move this negative 2x to left side, 3 to the right side. X plus y, 2x plus y is 1. 4 minus 3 is 1. So this is a general form of the required line. You can use either one. Yes, the problem just say find any equation. So this is the answer. You can stop here. If you want to write the general form, this is also correct. Either works. Either works. You don't have to pick up one because the problem does not require the specific form. Okay? Okay, so that's the slope, the point slope form. Right? Okay, so in the geometry, two parallel lines share the same slope because they share the same direction. Slope just give us a direction. There's another special relative positions for two lines. Two lines are not parallel. Parallel, they never touch each other. They have the same direction. If they are not parallel, they will definitely intersect. Two lines have only two relative positions. Parallel, no intersection. Or intercept, there's one intersection. There's only one intersection. With this one intersection, sometimes they form the right angle. We consider that as a special case. We call that perpendicular lines. Perpendicular lines. When they form a right angle, we say two lines are perpendicular. Two lines are perpendicular if they form a right angle. So we want to see the relation from the equation about two perpendicular lines. So we're not going to discuss the detailed proof, but we will directly give you the idea. So two non-vertical lines are perpendicular if and only if the product of their slopes is negative. The product of two slopes is negative 1, then these two lines are perpendicular. They form a right angle. Okay, so and here again, because we talk about slopes, we only consider the vertical lines. But we know that which line is perpendicular to vertical line. If you have a vertical line, only horizontal line is perpendicular to it. If you have a horizontal line, only vertical line is perpendicular to them. So for the perpendicular pairs, horizontal, vertical, they are always paired. That is a special trivial case, so we don't put it in the theorem. If they are not in this special case, one is horizontal, one is vertical. If they are in the other general positions, then this theorem says they are perpendicular. Two lines are perpendicular if and only if you can compute the slopes, you make a product, the product is negative 1. Okay? So in the textbook, there is a detailed computation. The computation depends on the Pythagorean theorem, and we're not going to go through that detail. But just remember, perpendicular lines, the slope is negative 1. So m1 times m2 is negative 1. m1 times m2 is negative 1. And sometimes when you use it, it's equivalent to say m1 is equal to negative 1 over m2, or you can use m2 is negative 1 over m1, whatever way. Okay, so the simple example will be the following. If a line has slope three halves, then any line having slope negative 2/3. You see here, negative 2/3 times 3 halves is exactly negative 1. Any line having slope negative 2/3 is perpendicular to it. Any line have this slope is perpendicular to it because the product of these two slopes is equal to negative 1. The product of these two slopes is equal to the negative 1. Okay? Okay, now let's check. Example. What is the example? Example is the following. I have a line. I have a point. I want to draw a line containing this point and perpendicular to the given line. I want to do this job. And point is given. The point is given, so we need the slope in order to write down the required line. The slope is related to the old slope, original slope. The old slope, the relation is that the product of these two slopes is negative 1. Not like the parallel. Parallel means they have the same. This is a product equal to negative 1. Find an equation of the line that contains the point 1, 2, 1, negative 2, 1, negative 2, and is perpendicular to the line x plus 3y equal to 6. The graph two lines. Graph two lines. Okay. Point is given, so we need the slope. Slope is related to this one, so let's find the slope first. X plus 3y equal to 6. 3y is a negative x plus 6. We move x to the right side and divide the equation by the coefficient of y. So negative 2. Negative 1/3 times x plus 2. Okay, so the slope, let's call it m1, is negative 1/3. Two lines are perpendicular. Then m2 is equal to negative 1 over m1. Check here, we wrote it here before. m2 is negative 1 over m1. You always have this. So you actually get negative negative cancelled. You flip 1 over 3, you get a 3. Negative reciprocal. So m2 is 3. The slope of the required line is 3. So you have a point, you have a slope, the equation. The point slope form is y minus negative 2 is equal to 3 times x minus 1. Okay, so here you're going to use this point information. You use the slope, you have a point. And let's simplify. Okay, so we already finished the question. Find the equation. This is equation. You don't do anything else in the exam. I'm going to do some computation to let you to see the equation in the general form, but that's not the required steps for the problem. Okay, so here's y plus 2 is 3x minus 3. We move 3x to the left side, 2 move to the right side. Negative 3x plus y equal to negative 5. Negative 3 minus 2, negative 5. So this is a correct answer. This is also correct, but it's general form. Either works, either works. Okay, we'll finish the solution of an equation. Let's graph them. Let's graph them. Okay, so from here, from this equation, we see the slope is negative 1/3. The intercept is 2. I make it bad. 1 and 2. Negative 1/3. Negative 1/3, you go 3 to the left, 1 to the up. This point, this is a 3, 1, here, that's here. This is x plus 3y equal to 6. X plus 3y equal to 6. And this one, where's here? It goes negative 2 and 1. 1 and negative 2. 1 and negative 2. and slope is 3. Slope is 3 means you go right 1 unit. 3 is 3 over 1, right? So 3 is 3 over 1. Run is 1, rise is 3. So 1, 1, 2, and 3. See, it's not too bad. Well, with my plotting, it's not very bad. So they look like they are perpendicular. Not very bad. Okay. Okay. We still have a few minutes. Let's make those two problems more machinable. If two lines parallel, two lines are parallel, they will have definitely something like this. Let's not use C1, C2. Let's just use C and D. Two lines are parallel. They must have AX, BY, C, one real number. AX, BY, D, a different real number. So check here. Check where's our problem? Here, this one. You see, this example, the given line is 2x plus y equal to 6. Here the general form is 2x plus y is 1. They share exactly the same left side, only different right side. Okay, so with this observation, we can actually do a problem like this. So let's redo this example. We have a point 2, -3. We have the given line 2x plus y equal to 6. We're looking for the line containing the point parallel to this given line. Remember that? I'm sorry, you don't see it. Yeah. I was trying to just use this example. See, here is the 2x plus y equal to 1. This is 2x plus y equal to 6. They share the same observation. So I'm trying to point out another way. You have a given point, you have the given line, you need the equation of the line containing the given point parallel to the given line. Okay, so what's the strategy? You let 2x plus y be b equal b be the equation. Two x plus y equal to b be the equation of the line. Then this line contains a point, means x is 2, y is -3. You can satisfy the equation. Two times 2 is 4, plus -3 is 1, so b is 1. B is 1. B is 1, the equation, the required is 2x plus y equal to 1. See, that's exactly this equation. So for the parallel, so this is we cannot say it's quick, but this is a different way to get the answer. If you talk about two parallel lines, you can always assume the xy part is identical to the given point. This is b, not 6. The xy part is identical to the given equation. It is identical to the given equation. The only different part is this constant number. To determine the constant number, you use the coordinates of the given point the given point satisfy the equation, you can determine the unknown constant. Okay, so two lines are parallel, then you have such case. If two lines are perpendicular, for example, two lines are perpendicular. Let's check this example. We just did this example. One x plus 3y, negative 3x plus y. What's that? If one line has this equation, a, b, the other line will have negative ba. You switch the order. You may have this, or you have this, or bx minus ay. Because you multiply this equation by -1, you can move this negative sign inside. It doesn't matter, just focus on one part is enough. Ignore one. Okay? Okay, now let's say how do we get this perpendicular case quickly. So the given point 1, -2, the given line x plus 3y equal to 6. So how do we quickly do it? Let negative 3x plus y be b equal b, be the equation. Negative 3x plus y equal b, be the equation. You just switch the order, switch the coefficients of x and y. The coefficient of x becomes y, coefficient of y becomes coefficient of x. Switch them. And then you put a negative sign. You can put it for x or you can put it for y. Just put it for 1. Just 1. Okay? Add additional. And then this the coordinate of the point satisfy the equation. So x is 1. Y is -2. Let's compute. -3 times 1 is -3, plus -2 is -5. B is -5, so -3x plus y equal to -5. See, that's exactly what we got. Okay, so that's the case. Let me see if I can find a proper, no, I don't have time. Okay, we stop here, and possibly in the next video, I'm going to give you 2 more examples about this method. This method is like a machine. It does not talk about the detail what is a reason. And here we can do that because these two forms will share the same slope. We can do this because the product of the slopes is -1. Okay, and that's a reason one place you must add a negative sign because you need a negative 1. Here the same thing, so you cannot move the positions. Okay, we stop this video. We will continue with another video. Thank you.